Hello everyone. In this video we will learn about the general equation of a straight line and also we will learn how to transform them into the different forms of the equations of the straight lines. We know that a first degree equation in two variables, or we call it a linear equation in two variables, represents a straight line. Like ax plus by plus c equal to 0. This is the general equation of a straight line. In two-dimensional coordinate geometry. A is known as the coefficient of x and B is known as the coefficient of y. C is the constant term. Like if we have an equation 2x plus 3y equal to 6, or we have 3x minus 4y equal to 8. These are representing straight lines. So these are the general equations of any of the straight line. Now we'll learn how to reduce them into the different forms of the equations of the straight line. The first form of the equation of the straight line is slope-intercept form, which is y equal to mx plus c, where m is the slope of the line and c is its intercept on the y-axis. Now how to reduce the general equation in this form? The general equation of the line is ax plus by plus c equal to 0. To reduce this, we will compare this with this equation. What we are finding here? We are finding that only y is on the left and other two terms are on the right side. So here also we will do the same thing. We will keep only the term with y here on the left and other two terms on the right we will transpose. So we are finding here by equal to minus ax minus c. Now we want only y. So we will divide the equation by b and we are getting y is equal to minus a upon b into x minus c upon b. What we find here? Minus a upon b is the slope of the line, that is m. It means we are finding m is minus a upon b. That is what? That is coefficient of x upon coefficient of y. What about the intercept? Compare this. Here we are finding the intercept c is minus c upon b. That is minus constant term divided by the coefficient of y. These two can be used as a formula to find out the slope of the line and also to find out its intercept on the y-axis. See, like we have one of the examples, suppose we are given an equation 3x minus 5y is equal to 4 and we have been asked to find out its slope. First we will see what is a and what is b here. Here we are finding a is 3 and b is minus 5. Then we can find out the slope of the line, that is m minus a upon b. It is minus a means 3, b means minus 5, so it comes as 3 upon 5. Like this, without converting into the slope intercept form also we can find out the slope of the line and also we can reduce it in the form by this particular algorithm. The second form is intercept form, that is x upon a plus y upon b equal to 1, where a is x intercept and b is the y intercept of the line. Now general equation is ax plus by plus c equal to 0. We have taken here the coefficients of x and y as capital A and capital B. Why it is? Just to make the difference between the coefficients here, or the intercepts we can say, and the coefficients here in the general equation. We have the constant term on the right. So we will transpose the constant term to the right here, that is ax plus by equal to minus c. Now we want only one here. So what we will do? We will divide the equation by minus c, and hence we are getting here ax upon minus c plus by upon minus c equal to 1. We want only x and y in the numerators here. So what we will do? We can write this as x upon minus c upon a plus y upon minus c upon b as 1. It means if we compare this equation with this, we are finding here a is minus c upon a. That is the x-intercept or intercept of the line on the x-axis. B, that is minus c upon b, that is the intercept of the line on the y-axis. So like this we can compare the given general equation in intercept form and find the intercepts. Here we can remember one more thing, that if we have any of the equation ax plus by plus c equal to 0 and we want to find out its x-intercept, for x-intercept what we can do, put y equal to 0. Because we know that y coordinate of every point on the x-axis is 0. If we substitute y is equal to 0 in this, what we get? We are getting ax plus b into 0 equal to minus c, transposing c onto the right. Are we getting here ax is equal to minus c, or we can say x is equal to minus c upon a? See now, for y-intercept, we can put x is equal to 0 because x coordinate of every point on the y-axis is 0. And if we do that here in this, we are getting a into 0 plus b into y is equal to minus c. Or we can say b into y is equal to minus c, or we are getting y is equal to minus c upon b. It means just to find out the intercepts of the line on the x-axis, y-axis, we can also use this particular method to substitute y equal to 0 and x is equal to 0 in the equation. To convert it into the intercept form, we will use this particular algorithm. The third form is the perpendicular or normal form, which is x cos alpha plus y sin alpha is equal to p, where alpha is the inclination of the perpendicular to the line from the origin and p is its length. So any of the general equation ax plus by plus c equal to 0 can be reduced to this form. Transpose this c onto that side, we are getting ax plus by is equal to minus c. Now here we are finding the coefficient of x is cos alpha and that of y is sin alpha. To reduce into this form, what we do to make it the easy concept, we can take a triangle, that is right angle triangle, in which one of the angle is alpha. If its base we are taking as a and the perpendicular we take as b, we know the hypotenuse here will be root of a square plus b square. That is by using the Pythagoras theorem. Now if we divide this equation by root of a square plus b square, we can reduce it into this form. So what we do, we will write here dividing the equation by root of a square plus b square. We get here a upon root of a square plus b square into x plus b upon root of a square plus b square into y equal to minus c upon root of a square plus b square. See, we want it to be positive. So we can multiply the equation by minus 1, we are getting minus a upon root of a square plus b square into x plus minus b upon root of a square plus b square into y equal to c upon root of a square plus b square. So what we find here, that cos alpha is minus a upon root of a square plus b square. Sin alpha is minus b upon root of a square plus b square, and p is c upon root of a square plus b square. This is the length of the perpendicular on any line from the origin. So by converting this equation into the normal form, we could see that the length of perpendicular from the origin on a line can be given by c upon root of a square plus b square. This we can use as a formula. Let's take one example. Suppose we are given a question, find the distance of line 3x plus 4y equal to 25 from the origin. Then we can see 3x plus 4y equal to 25 is the line, and we can see here the perpendicular distance p is c upon root of a square plus b square. If already the constant in the right, we can take it as a positive value. So we can write this as c means 25 upon root of a means 3, 3 square, b means 4, 4 square, that is 25 upon root of 9 plus 16, that is 25, 25 upon root of 25, or we get 25 upon 5, that is 5 units. So like this we can make use of this as a formula and find out the length of perpendicular or perpendicular distance of a line from the origin. We will discuss now one more problem on the reduction of the general form of the equation into the perpendicular or normal form, and that is reduce the equation of the line x plus root 3y minus 1 equal to 0 in the perpendicular form and find its distance from the origin. To find the solution, what we do, we will write the equation x plus root 3y minus 1 equal to 0. Transpose 1 on that side, we are getting x plus root 3y equal to 1. Now we are finding here that a is 1 and b is root 3. If we find the value of root of a square plus b square, that is root of 1 plus 3, or we can say 2. Divide the equation by 2. Divide the equation by 2. What we get? 1 upon 2x plus root 3 upon 2y equal to 1 upon 2. Now we can see very well here that cos alpha here is 1 by 2. Sin alpha here is root 3 by 2. So in case we want to find out the inclination of the perpendicular from the origin to the line, that also we can do by finding the value of alpha from here. And also we are getting p is 1 by 2, that is the perpendicular distance of the line from the origin. So we can say therefore distance of line from origin is equal to 1 by 2 units. In the next video, we will learn about the symmetric or parametric equation of a line and also the parametric coordinates of the point on a line. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.